Hi, welcome to part 8 of the Recursion video series. In today's video, we'll look at Leetcode problem 17, letter combinations of a phone number. Quick disclaimer before we proceed, I changed the mapping of every digit so that I can fit a 3-digit numbers combinations on the board. But even if you change the mapping of the digits to letters, the solution remains the same. So I have a Java solution to the actual Leetcode problem in the description below. That beats 100% in speed and 70% in memory. So you can copy paste that and play around with it. So without further ado, let's get started. So let's see what the problem is. Suppose these are the mapping of digit to letters. And I ask you, tell me every possible way I can do 0, 1 with just letters. Okay. So what if I say AC? What will you do? A is 0, C is 1. That is 0, 1. What if I say BC? B is 0, C is 1. That is 0, 1. What if I say BD? B is 0, D is 1. That is 0, 1. And there is, let's see, AC, BC, BD, AD. AD. That's again 0, 1. So there's 4 ways you can do that. So basically they'll give you digits, and based on the mapping, you have to figure out every possible way you can come up with the letter combinations. So let's say the input is 2, 3, 4. So they're gonna pass you a string. The input is 2, 3, 4. If you were just doing it with pen and paper, how would you do it? Or let's take smaller. Let's just take 2, 3. 2, 3, 4 will come to this solution. But let's just say take 2, 3. So if I was doing this with pen and paper, I will say 2 can be either E or F. Right? So my first digit, if I was just doing 2, 3, my first digit can either be E or my first digit can be F, because it's E and F are 2 and 2 is the first digit. So my first letter can be E, first letter can be F. Then if I take 3, 3 means my next digit, my next letter can be either G or H. So I can have EG or EH, and if F is the first letter, FG or FH. So these are the 4 results I have for 2, 3. EG, EH, FG, FH. So how do we do it in a decision tree? If you've been following my previous examples, anytime you solve a recursive or backtracking problem, you should, without fail, always start with a decision tree, because that makes writing the solution much easier. So suppose so this is a decision tree. This is the number input, and this is the result we've calculated so far. Okay. So first digit is 2. So this guy is gonna say, like I said in my previous videos, every node in a decision tree does one part of the job and gives the rest to the next. So this guy is gonna say, okay, I will figure out what all the first position can be, because first digit is 2. I'll figure out what all the first position can be. You guys do the rest. So 2 can be E. So it will say, okay, my first letter is E, or 2 can be F, first letter is F. Okay, and it takes 2 out. Now this guy tells him that I figured out for 2, you do the rest. Similarly, tells this guy also says, I figured out for 2 because I've taken 2 out of the remaining digits. You figure out the rest. This guy will say, okay, I will figure out for 3. Okay, he's gonna take 3 out. So see, he's not passing 3 here. He's gonna take 3 out, and he's gonna say, okay, 3 can be either G, so my next letter is G, or 3 can be H, my next letter is H. He tells this guy, these are your first 2 letters, EG, and tells this guy, these are your first 2 letters, EH. Now you go figure out what can be for 4. This guy says, okay, 4 can be I or J. So this guy tells, okay, EGI, you figure out for what is the rest. To this guy, EGJ is my result, you figure out for the rest. When we reach here, these people see that there is no other digits to process. This is empty. So then it will say, okay, now I've reached the base case, I'm going to write this out to the result. So EGI is one result, EGJ is one result. So basically at every node in your decision tree, you're going to explore the path for every letter for that digit. So for first one, you take 2, you can have E, or you can have one path where first letter is E, one path where first letter is F, and if there's more letter, one path for that letter. And then the next guy, the same thing. Now that I have E as the first letter, For the next letter, 3 what all are there? G and H. So next letter can be G, I'll explore one path for that. Next letter can be H, I'll explore one path for that. If there's more letters, explore a path for that. In our example, there's only 2. And the base case is when you have no more digits to pull out of it. So this is pretty much the solution. One thing to keep in mind here is there is no backtracking. The reason is the numbers we're working with, we're passing every stack frame a new copy for itself. So this gets its own copy, this gets its own copy. The only thing that is shared between the stack frames is the result list, but that is okay because for the result we don't need to do any backtracking. We just keep adding to that list. So this is not exactly a backtracking problem, this is just a recursion problem. But depends on your solution. If you do it in a different way, it could be a backtracking problem where every stack is playing around with the same numbers or same reference type, then that will be a backtracking, like my previous examples. But in this one, it's not a backtracking, it's just a recursive solution. So what else is there? Yeah, so another thing, like I say in most of my examples, to remember is the order in which it executes. The first call it gets, it's not gonna start this and this simultaneously. What it's gonna do, unless it's a multi-threaded program, we are talking about single-threaded. So in a single-threaded program, it comes here, it will explore this path. Once it comes here, it will explore this path. Once it comes here, it will explore this path. Write this to the result. This will be, so if your stack frame is like this, let me see if I can put a stack frame here. So your first stack frame will be created for this method. Next stack frame for this method. Next stack frame for this method. Next stack frame for this method, okay? This gets returned to the result. This pops off the stack. You're back here on your stack frame. Then you come here, another stack frame is added for this guy. This is printed out the result, popped off the stack, you come back here. This is popped off the stack, you come back here. Then you come here, this is another stack frame. You come here, this is another stack frame. Once this is out of the result, this comes back here, popped off the stack. Here, another stack frame. So basically, this is the order you'll go in. First come here, 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 go back here, come here, go back here, come here, come here, 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 up, here, like this, 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 this. So this is how your stacks frames would be added and popped off the stack. So yeah, that's all I had to cover today. I'll be adding a few more videos on recursion later. Thank you.